This triangle with vertices at 10, 0, 0, 10, and 40, 40 is symmetric with respect to the line L. So if I draw these 3 points, we've got 1 point here, 1 point here, and then we've got another point out there. So we've got 10, 0, 0, 10, and then we've got 40, 40. So the only way that these could be symmetric is with a line running right through the middle, like right there. Because the only way you can have a line that's symmetric with these 2 points right here is if they run right through the middle at 5, 5. And the only line that passes through 5, 5 and 40, 40 is going to be the line y equals x. Now notice that these 2 points right here are symmetric. 0, 10 and 10, 0 are symmetric. And notice they're symmetric because they flip-flop. So we're asked about the point 4, 11. So that's going to be roughly here. It's not drawn to scale. But what matters is, in order for it to be symmetric, it has to be 11, 4. So this information right here, the distance, is not really important. You don't really need that in order to establish, because there's only one point that's symmetric here with the line y equals x, and that's 11, 4.